So now here is a very good challenge for you. It's a good way to practice your laws of exponents. So if 3 to the 2n plus 9 to the n plus 1 is equal to k, what is 3 to the 2n plus 1 in terms of k? Let's start with this. Here I have a base of 3, and I want to get something with a base of 3 in terms of k. And here I have a base of 9, but 9 comes from a base of 3. So I know that 3 squared is equal to 9. So there's that base of 3. So let's try substituting that in for 9. So we have 3 to the 2n plus, well, this 9 is going to be 3 squared, but it still has this power, n plus 1, and that's going to be equal to k. So now what do we know about multiplying power? So if I have 3 squared to the n plus 1 power, what am I going to do? Do I add these together? Do I multiply them? Well, you're going to multiply them. This is one of our rules. So we're going to leave this 3 to the 2n alone, plus 3. We're going to distribute this 2 because this is like saying 2 to the n plus 1 is equal to k. So we have 3 to the 2n plus 3 to the 2n plus 2 is equal to k. But what else do we know about this kind of exponent? Well, we know in order to get an addition sign up there, we have to multiply something with the same base. So I can say 3 to the 2n, we're still leaving that alone, is equal to 3 to the 2n times 3 squared. Because remember, when we're multiplying something with the same base, we have to add the exponents. That's still going to be equal to k. So now this is where a little bit of algebra comes in. I see that both these terms have a factor of 3 to the 2n. So what I'm going to want to do is to take that out of this entire equation. I want to factor it. So we have 3 to the 2n. If I take 3 to the 2n out of 3 to the 2n, I'm left with 1. Plus, if I take 3 to the 2n out of 3 to the 2n times 3 squared, I'm left with 3 squared. And that's all going to be equal to k. So now, I want to simplify what's in the parentheses. So I have 3 to the 2n times 1 plus 9 is equal to k. So 3 to the 2n times 10 is equal to k. So now what do? Well, remember that my final goal is to find 3 to the 2n plus 1 in terms of k. So let's get rid of this 10 on the left-hand side because we just want something similar to 3 to the 2n on the left. So now we have, if we divide both sides by 10, we have 3 to the 2n is equal to k over 10. So now let's think back again to our laws of exponents. Here I'm adding 1, and it's similar to what we did around here. When I am adding an exponent, it's like multiplying something with the same base. So, saying 3 to the 2n plus 1 is like saying 3 to the 2n times 3 to the 1. Because here we're multiplying something with the same base, and so we add it in the exponents. And we know that 3 to the 1 is equal to 3. So let's multiply both sides of this equation by 3 to the 1, or 3, so that we can have the left-hand side look like what we want. So we have 3 to the 2n times 3 is equal to 3 times k over 10. So our left-hand side becomes 3 to the 2n plus 1 is equal to 3 times k over 10. And there you have it. Here's just a summary. Remember, we found by using laws of exponents in algebra that 3 to the 2n is equal to k over 10. And we also used our laws of exponents to know that 3 to the 2n plus 1 is the same thing as 3 to the 2n times 3. So from knowing that, we can multiply both sides by 3, resulting in our final answer of 3 to the 2n plus 1 is equal to 3 times k divided by 10.